Hello everyone, so we're starting a new lesson today. The topic is called Completing the Square. This is, I would say, not a favorite of many people. It's one of those things you just have to get done. Each problem that you're going to do takes kind of a lot of writing, a lot of steps. So the trade-off is that there's not a lot of them. So if you look at the odds, you only have 4 that you are going to be asked to do. But you see all the space I gave you underneath each problem. That's because there is a lot of writing. Okay, let's talk about this completing the square. So we've covered the square root method. I'm going to change colors here. The square root method was not too difficult at all, really, and it solves equations like this right here, x squared minus 9 equals 0. So I'm going to work through this real quick. It's fairly simple. We would start by adding 9 to move it over to the other side. X squared equals 9. Then to cancel out the square, you take a square root, and you do that at both sides. When that cancels out, it isolates x. And then one of the special details in the square root method is that if you ever use a square root to solve an equation, you have to put plus minus down on your answer. And then, of course, the square root of 9 is 3. So you could say, here's your answer, positive or negative 3. The answer keys on most of these problems actually wrote the answers like this, x equals negative 3 or x equals positive 3. Or you might see those braces, negative 3 comma positive 3, like those are the 2 answers. So whatever, but that's the method. Now, my dogs are here and they're about to fight with each other, so hopefully it doesn't become a problem. All right, they've calmed down. All right, the square root method does not solve equations like this, meaning an extra x term in there. X squared plus 2x minus 9 equals 0. You could still add the 9 to move it over to this side. You get something like this, x squared plus 2x equals 9. But you can't square root to cancel out the square because you'd also have to square root this. In fact, what I've written is technically wrong. You'd have to square root the whole thing like that, and this won't simplify, and you just get stuck. So the square root method doesn't apply on every quadratic equation. It only applies on special ones that are set up like that. So there's this completing the square, which is a trick that kind of makes the square root method work on this different type of problem. So you can use completing the square to solve all quadratic equations, not just the ones that look like that. So that's kind of what we're learning today. Now we're going to focus on the simpler quadratic equations. By simple, I mean ones that look kind of like this. Not simple look kind of like that, and the difference is the lead coefficient. When you have an extra number in front, it actually makes this process a big pain. You get fractions, you get extra steps, and it's awful. It can still work, and if this were a normal school year where we had more time in the classroom, I would go over this and it'd be part of the lesson. But for the sake of simplicity right now, being online, we're not going to cover these non-simple problems. We're only going to stick with what I'm calling the simple ones. Now, simple isn't easy. Don't get that confused. Well, I mean, the math you're going to be doing is adding, subtracting, multiplying, dividing, and factoring. So, I don't know, maybe you will find it easy. That's up to you. There's just a lot of steps. All right, a key part of this trick is finding something called the magic number. It's not technically called the magic number. You're not going to look in any math book and find that as like a vocabulary word in the glossary. But I call it the magic number because it's easy to remember. So basically, if you're given a quadratic like this, the magic number is where you take b, divide it by 2, and then square it. So b is that number there in front of x. So, for example, if we had x squared plus 8x plus 5 equals 0, the quote magic number, you take that 8, cut it in half, and square it. So 8 cut in half is 4, and 4 squared is 16. Now, what do you do with that magic number? That's not the answer. That's just a step in the process. That's what I'm going to get into as we go through here. So I'm just sort of preparing you for this fact that I'm going to be using the phrase magic number over and over, that it's part of the process, is not the answer or anything, but I just want you to be ready for that. Okay, so let's get to this. I'm going to use my even problems as examples like usual and assign the odd ones. So number 2, we're supposed to solve this equation, this quadratic. Quadratic means it has x squared or k squared, whatever the variable is, it has a square in it. That's what quadratic means. We're going to solve it using the the completing the square process. Okay, now the first thing you want to do when you're doing this completing the square is move the constant term to the right side of the equal sign. The constant term is the term without a variable. So in this problem, the constant term is minus 40. In this problem, the constant term is positive 76. So whatever that constant term is, we're going to move it to the other side of the equal sign. So here I'm going to add 40 to get it over here. So that gives me k squared minus 18k. Now I'm going to intentionally leave a space here, equals 40. This space is important. Always leave a space there. We're going to fill it in. And in fact, we're going to fill it in with the magic number. So the next step is going to be find magic number and ... I'll complete that thought in just a minute. So the magic number here in this particular problem, let's see, I'll do it up here. It's going to be negative 18 divided by 2 squared. Well, negative 18 divided by 2 is negative 9. And negative 9 squared is positive 81. In fact, your magic number always is positive, because when you square a negative, it turns positive. Or if it was positive in the first place, it would stay positive. So I'm going to actually write that down. Magic number, note, always positive. So in this problem, the magic number is 81. I'm going to add 81 right where that space was. But remember with equations, if you do anything to one side of the equation, you have to do the exact same thing to the other side of the equation. So you also have to add 81 to the right. We already moved the constant over to the right. Now we need to add 81. So the right-hand side becomes 40 plus 81, so that's 121. Okay, the left side of the equation, we are going to factor. And we did a brief review of factoring, so this is trinomial factoring. K times k is k squared. Now we need two numbers that multiply to 81 and add up to negative 18. So normally when you do factoring, this is where you got to really kind of think things through and process it and figure out what that could possibly be. But here, when you're completing the square, it's easier than normal factoring. It's always going to be a lot easier. You see this negative 9 right here? That's what it has to be. Negative 9 times negative 9 is positive 81, and negative 9 plus negative 9 is negative 18. So that is always going to work out like that. Those two numbers equal each other, and they kind of equal the in-between step of finding the magic number. Now the fact that k minus 9 and k minus 9 are the same thing, they're identical, right? And it always works this way. This is, like I said, it's a trick. K minus 9, you can call that k minus 9 squared, because in math, if you multiply something by itself, that's a square. Hold on while I make that a little neater. So k minus 9, well, my handwriting is horrible. Okay, anyway, k minus 9 squared equals 121. Now, because we have something squared, right here, squared, we can use the square root property. Square root both sides of the equal sign. It's going to cancel out that square, and you get k minus 9. The other side, remember, you have to put plus minus, and then the square root of 121. Well, the square root of 121 is 11. Now we can isolate k by adding 9 to both sides. We get k equals 9 plus or minus 11, which is math that you can do. 9 plus 11 and 9 minus 11. That plus minus means it could mean positive or negative, but it also can mean add or subtract. So 9 plus 11 is 20, and 9 minus 11 is negative 2. So the two answers, k equals negative 2, k equals 20. Or probably our answer key, when I scroll down to check it, is going to look like that. You know, I'm not fussy on how you write your final answer, just as long as you get it right and you understand what you're doing. So there it is. Well, 20 and negative 2 and 20, same thing. I like that as the answer, to be honest. That's my favorite way to write the answer, so whatever. Okay, so, oh, find the magic number and dot dot dot. I never did finish that thought. And add it to both sides of the equal sign. Now, I suppose I should actually kind of maybe keep going with this idea. The third step we did in this process was factor. The fourth thing we did was square root property. And then the fifth thing we did at the end was just to like simplify it. I'm going to write solve and simplify, because the fifth step is going to vary from problem to problem. So here, let me take this as kind of our step-by-step process, and I'll change the color here to maybe like a green. There we go, just so it stands out. So that's something we can refer back to if we need to. Okay, so a few examples, and hopefully you'll get this. If everything didn't sink in there, hopefully the more I do, the better it becomes. Now, these two numbers were whole numbers. We are going to get into some radicals, and we're going to get into some imaginary numbers. So everything we've been doing still sort of applies here. All right, so number 4. The first thing I need to do is move this term to the other side. If it's positive on the left, it's going to turn negative on the right. So we'll do that, and you see where I left the space. Now we got to fill in that space with the magic number. So I got to take half of negative 20 and square it. Half of negative 20 is negative 10. Negative 10 squared is positive 100. So there's my magic number, positive 100. If it was, it's always going to be plus. It's always going to be plus, so put plus 100 on both sides. On the left-hand side, we need to factor. On the right-hand side, negative 76 plus 100, that's 24. So here, n and n, what two numbers multiply to positive 100 add up to negative 20? It's got to be the same number. And like I said, it's actually going to be that number right there, minus 10 minus 10. So to complete the square means to put this as n minus 10 squared. So the trick is we've turned this problem into a square problem, if that makes sense to you. So what have I done here? I did step 1 where I moved the constant term to the right. I did step 2 where I found the magic number, added it to both sides. And I did step 3 where I factored. Now I'm going to use the square root property. Square root both sides. This cancels out. N minus 10 equals plus minus. That's kind of important. Whenever you use the square root property, you have to put plus minus in your answer. The square root of 24. Now let me take a little time out, little sidebar. 24 is not a square number. If it was 25, of course, you know the square root of 25 is 5. That'd be wonderful. But it's not. However, 24 is 2 times 12, and that's 2 times 6, and that's 2 times 3. We do have a pair of 2's here. So we can simplify this. Square root of 2 squared times 2 times 3. This is a whole other lesson that we did, simplifying radicals. The square root and the square mean you can simplify that, or square root prison if you learned it that way. So I can bring out a 2. The other 2 and 3 don't have a power. They are not squared, so I can just turn those back into a 6. 2 times 3 is 6. So this becomes n minus 10 equals plus or minus 2 square root of 6. So if you can simplify a radical, you are expected to do that. Now, are we done? Is n isolated? No, I got to add 10 to both sides. Plus 10, cancel that out. Now, how do I do 10 plus or minus 2n? Well, first I'm going to write it down. 10 plus or minus, did I say 2n? I meant 2 radical 6. 2 radical 6. Can you actually simplify this? 10 plus 2 is 12, and 10 minus 2 is 8. I hope you said no, because they are not like terms. The 2 is attached to the radical 6. It'd be kind of like 10 plus 2x, or 10 minus 2w, or whatever variable. When one has a variable and one doesn't, they're not like terms, so you cannot combine them. The radical 6 here kind of works like a variable in the sense that it makes an unlike term. So our final answer is going to be 10 plus 2 square root of 6 and 10 minus 2 square root of 6. That, oh wow, I can't draw a circle. Awesome. All right, so let's check number 4 and see that that is right. And there it is. So when you get the radical business, these problems become a little more involved. Without the radical, it's not quite as bad. All right, so like I said, a lot of writing might not look like the most fun you're going to have today, but again, at least there's only 4 problems total. Let's do number 6. So step 1, I have to move the constant term to the other side of the equal sign. This plus 90 is going to become minus 90. Now, let me make sure that's an A. Find the magic number. I need to take half of 18 and square it. I'm sorry, half of negative 18 and square it. That's going to be negative 9 squared, which is 81. So I'm going to add 81 to both sides of the equal sign. Over here on the right, negative 90 plus 81 is negative 9. Over here on the left, I'm going to factor this, A and A. What multiplies to 81 and adds up to negative 18? That's going to be negative 9 and negative 9. Now, since these two factors are identical, you can put them together as a square and then continue to now use the square root property. To cancel out that square root both sides. This cancels out. I get a minus 9. It kind of stinks that my a's and 9's look like each other. Sorry about that. Over here, the square root of negative 9. Well, okay, we did the square root property, so we have to put plus minus on it. We're square rooting a negative, so remember, anytime you square root a negative, you can't really square root a negative, but you can make it imaginary, so that's I. And then finally, the square root of 9. What is the square root of 9? Well, that's 3. So really, it's a minus 9 equals plus or minus 3i. We're not quite done. We still need to isolate a, so I have to add 9 to both sides. So a equals. Now, you might look at this and say, oh, it's plus or minus 3i plus 9. You're not wrong, but complex numbers, if you recall, are written a certain way. A plus bi. So the imaginary term is supposed to be second for what it's worth. So I'm just going to write it as positive 9 plus or minus 3i. And that's technically right, but the answer key is going to split it up into 9 plus 3i and 9 minus 3i. Again, I being the imaginary number. Let's scroll down and check number 6. And there it is. 9 plus 3i, 9 minus 3i. Okay, so what have we done? We've done one problem, the first one, with a lot more steps, but the answers were whole numbers. And the reason there were a lot more steps probably is because of the first one, and I was trying to explain a lot more. The next one, same steps. I might have streamlined things a little bit, or is it the same? I can't tell. It's maybe about the same, I guess. But the square root did not simplify like up here. The square root of 121 is 11. That's just a whole number. Here it's a radical, and I needed to simplify the radical off to the side. Get down to this one. Same process, same steps, I guess. But we did square root a negative. So remember, anytime you square root a negative, it makes an imaginary answer. So you got to put I down. And then the square root of 9 worked out to be 3. So yeah, no radical in this one. Number 8, probably going to be the worst one on the whole page. Let's see. So first step, can you, at this point, know the first step? That would be good. Second step, magic number. This is something you probably aren't going to memorize and know for the rest of your life, but you get it in your head for this lesson, and for, until Christmas break, you should be in good shape. So you take the number in front of the v, or whatever that variable is, cut it in half, and square it. So half of 18 is 9 squared. 9 squared is 81. It's always positive 81, so we're going to add 81 to both sides. In fact, that's kind of like the last problem, isn't it? It's almost exactly the same, a little bit different. Okay, on the right, negative 92 plus 81 is what? Golly, negative 11? Is that right? Yeah, negative 11. Boy, I don't know why I can't process that. On this side, factor v times v is v squared, positive 9 multiplies to 81, adds up to 18. Or if in doubt, it's that number right there, positive 9. V plus 9 and V plus 9 can be completed into a square. V plus 9 squared equals negative 11. Now we cancel out the square by using the square root property on both sides. That cancels out. I get V plus 9. On the right, I have plus minus, right? Always have plus minus. The square root of negative 11. Well, we're square rooting a negative, which makes it imaginary. And we're square rooting 11, which is not a square number. Now, I could go off to the side here and say, all right, can I simplify it? I mean, that's what I did with 24, right? So why don't I do it here? Well, 11 is what we call a prime number. It does not break down into anything except 1s and 11s, which doesn't take us anywhere. So this one is just going to remain radical 11. We're not quite done. We need to isolate v, so I need to subtract 9 on both sides. I get v equals, and then just write down negative 9 plus or minus I radical 11, which you can rewrite as 9 plus I radical 11, comma, negative 9 minus I radical 11. So when I check myself for number 8, that should be the answers, and there it is. Okay, that's the whole lesson. Now, I've set this up to be fairly straightforward, so when you do number 1, it's going to be very similar to number 2, meaning you should get whole number answers. Number 3 should be very similar to number 4. Going to get radical answers, and you're going to have to do some simplifying. Number 5 is going to be a lot like number 6. You'll get, I'm going to call this a somewhat easier imaginary answer because there's whole numbers involved. And then the last one should be kind of like number 8, where you still get imaginary answers, but maybe there's an extra radical in there. All right, that is about all that I have to say. If you are lost or confused, you can always go back and re-watch, see if it makes a difference. You can search completing the square in YouTube and find other teachers or other YouTubers who explain it. That might be helpful. And of course, feel free to email me or send me a comment, and I can try to answer questions as quick as I get them. Until I talk